Today we're going to work on Unit 2, Lesson 3, and this is going to be a really big lesson. We did cover this in Foundations last semester. If you want to go back and watch this, it is broken down into 3 separate videos from last semester. Unit 4, Lesson 6 is the graphing when you have M and B. Unit 5, Lesson 1 is writing an equation given a point and a slope. And then Unit 5, Lesson 2 is when writing the equation of a line when you are given 2 points. So it breaks it down into 3 separate lessons. Today we're going to put it all together and we're going to review all in one lesson. So let's start right out with how do we write the equation of a line if they give me the M and the B? So the first thing that we're going to do is we're going to write down y equals mx plus b. I want you to always make sure that you're putting it into that format. So let's go ahead and write down, for example, 1, y equals mx plus b. That's the format that we're going to use. Next, we're going to substitute the slope in for m and the y-intercept in for b. So here my slope is -5, so I'm going to put that right there. And my b is 2, and that's going to go at the end there. So if I write this equation officially, it would look like y equals -5x, and because that 2 is a positive 2, it'll look just like that. And that is the equation of my line, given my slope and my y-intercept. I want you to kind of look down through these next 3 examples, and I want you to identify for all 3 of them what is the slope and what is the y-intercept. And just pause the video for a moment. All right, welcome back. If you plugged in your slope and your y-intercept, these would be the 3 equations that you got. What I want to do is I want to simplify these last 2. So if I have a 0 for my slope, the way that I would simplify this equation, which is step number 3, simplify the equation, I would not put 0x there. I would just put y equals 3. What about example 4? How would I simplify this equation? And many of you already know the answer is we just don't have to write that 0 at the end. Okay, so that is writing the equation of a line if they give you the slope and they give you the y-intercept. Now, how would you write the equation of a line if they give you a graph to look at? So let's do these 4 examples down here. So I have a graph. The first thing that I'm going to do is write down y equals mx plus b. So you can see down below my examples 5 through 8, I've already written down y equals mx plus b for each example. Next, I'm going to use any 2 good points on the graph to help me find the slope. So identifying good points on a graph can sometimes be difficult. I try to rely on my y-intercept all the time, and then I am looking for a point on the blue line that crosses in on a perfect square, okay, right there. It crosses those boxes exactly in the middle, and that's what I'm going to use as my good points. Why don't you look at example 6 and try and see if you can identify 2 good points? All right, I also did the same thing that I asked you to do in example 6, except I tried to identify all the possible good points that I could see. So anything that you might have chosen should be showing up here. Now let's go ahead and do step 3. Find the y-intercept on the graph. So my y-intercept is blue, and I see my y-intercept right there at 2. This y-intercept is at -2, and that's the y-intercept. Step 2 was use the good point. Okay, and find the slope. I skipped over that. So from this first good point to this second good point, I would have to rise 1, 2, 3, 4 and run 1, 2, 3, 4, 5. So my slope here is 4/5. What is my slope in example 6? Rise 2, run 3. Rise 2, run 3. Rise 2, run 3, rise 2, run 3. So for any of those points that you might have chosen, it is 2/3. What would have happened? Let me do this in red. What would have happened if I found this is a good point and this is a good point? Then when I counted my rise and run, I would have gone up 4/6. And what does 4/6 reduce to? And the answer is 2/3. So I want you to be sure that this is reduced. Whatever you get for your slope should always be a reduced fraction. All right. And now let's go down to step 4. I'm going to give myself a little more room at the bottom here. And we want to do exactly what we did up above. Plug in the m and the b into this equation so that you can give me the equation of the line. And that should be 4/5. Whoops. And this should be 2/3. That's a +2, and that's a -2. All right, let's look at examples 7 and 8. Examples 7 and 8 don't exactly follow the rules as examples 5 and 6. I did go ahead and remind us of our Hoy and our Vux up at the top. And how did I know that number 7 was Vux? The reason that I knew that is because this is a vertical line, and we learned that on the other side of our paper, okay? So vertical lines have a slope that is undefined, all right? And then where does this line cross the y-axis? And the answer is it does not. So I put NA, not applicable, because it does not cross the y-axis anywhere. It only crosses the x-axis. So to write the equation of this line, you have to know where it crosses the x-axis. And it's right here at 6, at x equals 6. And so that is the equation of the line. That's exactly how you do it. X equals 6. And that's it. How does example 8 work? Well, this is a horizontal line. So I know because of this that my slope is 0. And then my y-intercept is right here at 3. And this line does not cross the x-axis at all. So when I write the equation, it's not going to have an x in it. So it crosses the y-axis right here at 3. So that is the equation of this line, y equals 3. And that's it. I am finished. So we've done examples 1 through 8. Let's go take a look at the other side of our paper. Examples 9 through 14. Now I did add some notes to the top of mine. So if you need to pause this video and add those notes, go ahead and do that. What we're going to do is we are going to, now given an M and a point. So I don't know the y-intercept anymore. I do know the slope though. There are two different methods that I taught you in foundations, and I want to review over both of those methods. The first method that I actually did teach you was the graphing method, so that you could use the graphs in the Cartesian plane to figure it out without having to do as much algebra. And that's a really good fallback method, except for the fact that it does not work 100% of the time. The reason that it wouldn't work 100% of the time is that to find your y-intercept, if it's a fraction or if it's an extremely large number, would be very difficult to do on this very small graph that I've provided to you in these examples. So we needed to learn the algebraic method as a backup for those times that you cannot graph it, okay? So let's do example 9 together. I'm going to walk us through those 4 points, but we're going to do the graphing method. So let's go ahead and make our X and Y axis show up better. Okay. So example 9, I have a slope of 2 and I have a point, 2 comma 3. Step number 1 under graphing method says to plot the point. So let's go over to 2 and up 3 and plot the point. Step 2 says use the slope as directions to get to the y-axis. So remember when we're graphing that we want to think of our slope as a fraction, okay? So starting at this point, if I go up 2 and over 1, up 2 and over 1, am I getting closer to the y-axis or further away from it? And the answer is further away from it. So this is where we would need to do that little trick I taught you, where you could change both the signs of the numerator and the denominator, and that will allow you to change directions in the graph. So now going back to that point, let's go down to back 1, down to back 1. And now I have crossed the y-axis. So that leads me right into step 3, locate the y-intercept. The y-intercept is right here at -1. And so what this now allows me to do is to write the equation of this line. So I have y equals, the m was 2, and the b is a -1. And that's the equation of the line. Fantastic job. I want you to practice doing that on your own, okay? I want you to try the graphing method for example number 10. All right, so I have done example number 10, the graphing method, and I have successfully written the equation of my line just doing the graphing method. Here's what I'd like for you to do. I would like for you to go ahead and practice 11, 12, 13, and 14, all doing the graphing method. All right, and then pause the video while you're working on these, and then come back in a few minutes and let's talk about them together and check our answers. All right, welcome back. I have completed the graphing method for all 4 examples. I showed all my work. I color-coded to help you see where I was using my slope and then finding my y-intercept. So go ahead and check your work for 11 and 12. Raise your hand if you have any questions for me. I know it might be kind of difficult to see these little teeny lines on your paper, so you might have a counting issue where you just didn't see it as well. But all in all, I feel like we should remember this from last semester. Okay, here's my answers for 13 and 14 as well. Now 13, I had to be kind of tricky with it. I actually did it, and then I realized that I was going to run out of graph. So I erased it, and then I drew it again, and I raised my x-axis up higher. So that way I could show you how to still use the graph, even though it goes down a little further than normal, you don't always have to center your origin. And then on number 14, this was tricky because I threw in an undefined slope in there for you. I still plotted the point 3, 6, and then I had to remember undefined slopes are VUX, and that will be a straight up and down vertical line, and it will only cross through the x-axis. So the equation will look like the number that it crosses on the y-axis, which is 3. So x equals 3. Great job. Now I'm going to back up all the way up to example 9 again. And I'm going to demonstrate for you how we use the algebraic method to solve number 9. We're going to do 9 and 10 together, and then I'm going to have you do 11, 12, and 13 for practice on your own. So the steps for doing the algebraic method at the top say, step 1, write down y equals mx plus b. Step 2, substitute the slope and the point in to that equation. So the point contains two values. It contains an x value and a y value. So I'm going to plug those in. The 3 goes in for the y, the 2 goes in for the x. And then don't forget that your slope is a 2. And then I'm going to bring down everything else. Now this is not a 22 plus b, so be careful that you either put a multiplication sign or parentheses. All right, so we've done our substitution. Now we're going to solve this equation for b. So 2 times 2 is 4. Bring down the plus b. To get the b by itself, I should subtract 4. And now I have b equals -1. And so I have discovered my y-intercept. So the very last step is to plug the m and the b back into the original y equals mx plus b equation. So my slope is a 2 and my y-intercept is a -1. And you can very plainly see that whether I do it the graphing method or the algebraic method, I will get to the same answer. All right? They're the same no matter which method I choose to use. So we're going to practice both during these notes. But when it comes to doing it on your own, you're allowed to use any method that you prefer. All right? So we've already done this one, the graphing method. Let's do it again, the algebraic method. Step number 1 says to write the equation y equals mx plus b. Step number 2 says to plug in the slope and then plug in the information that you get from the ordered pair, which is x is 4 and y is -3. And now I'm going to solve this equation for b. So 1/2 times 4 is 2. And now subtract 2 from both sides. And I get b equals -5. So I've now found my y-intercept. So I'm going to plug that into this equation. And remember that the slope was 1/2. And again, you can see that I came to the exact same conclusion doing this both methods. So here's what you're going to do now. You're going to pause this video. You're going to go down and you're going to do examples 11, 12, and 13 on your paper. And then I am going to show you how to do number 14. All right, so go ahead and pause the video. All right, here is my work for the algebraic method for numbers 11, 12, and 13. Take a look. If you need to pause this for just a minute to follow through my work, maybe see where you made a mistake. If you need extra help looking at your work, you're welcome to call me over. All right, I'm going to scroll down a little bit so that you can see the final answer for number 13. Again, notice that they're all the same answers as that I got from the graphing method. All right, and now what we're ready to do is we're ready to work on number 14 together. Okay, so I need to plug in the x and the y into this equation. So 6 and 3. And I've got a plus b here. And now I need to plug in my slope, which is undefined. Okay, undefined slope, which really means that I cannot do this method at all. Okay, it just isn't going to work for me, which is why I wanted us to do it together. So when it has an undefined slope, you really just have to know this method can't work. Okay, I really just have to know undefined is vertical. Vertical means I need to focus only on the x. So x is 3 in that ordered pair. So my equation will be x equals 3. And that's where I get the information from, is out of the ordered pair. All right. If this slope was 0, then I would look at the y value and say y equals 6. And that would be how I write that equation. So when the slopes are 0 or undefined, it's a little different. But we did great work. What I want us to do now is to work on the back side of our paper. So I am going to come over to the left, and I would like for you to pause the video for just a minute, jot down my notes for the graphing method, and be certain that you remember the slope formula because we're going to need to use it. All right, so I'm going to scroll down. I'll be using the notes from up above as we do the graphing method. Okay, we're going to start with the graphing method. So the very first step in the graphing method says to plot both of these points. So let me start out by drawing my x and y axes. And now I'm going to plot the points. So over 2 up 3, over 4, and up 5. So there's my 2 points. Step 2 says, find the slope using rise and run. So my slope then is up 2 over 2, 2 over 2. Alrighty. You could also say, remember to change your signs, you could also say negative 2 over negative 2, which would reduce to 1 or, 1, right? So my slope is 1. Step 3 says use the m to cross the y-axis. So what that means is use your slope until you cross over the y-axis. So if I go up 2 and right 2 again, it's not really going to help me get closer to the y-axis. So what I want to do is go down 2, left 2. And as soon as I cross the y-axis, I'm going to stop, because that is step 4. Identify the y-intercept. And in this case, it is 1. And now what you've done is you have found m equals 1, and you have found b equals 1. And now what you're going to do is write the equation of the line. So y equals 1 x plus 1. And that's my graphing method. Why don't you go down to example 2, and I want you to practice that exact same method for example 2. So here is my graphing method for example number 2. I plotted both the points. I counted from one point to the next my rise over my run. And then I didn't actually have to use my slope at all because one of my points was already on the y-axis, so I just had to identify where it crossed the y-axis, which was at 4, and ta-da, I have my equation. I have a slope and a y-intercept, so I'm done. And that method can be really quick and really easy once you practice it and get really good at it. But it does require a lot of graph paper. So remember that I do have a whole bin at the front of the room of those dry erase graph boards and some dry erase markers that you are welcome to use at any time. You do not need to ask for permission, but please just take good care of things and make sure that the lids are on the markers tight and that we are not bending the dry erase boards. All right. All right. We are ready to now change gears and go back to example 1, and we're going to do the algebraic method. So step 1 of the algebraic method says to label your x and y values from the 2 points that you were given. So let's go ahead and do that. x1, y1, x2, y2. Step 2 is to write down y equals mx plus b. So here's my step 2. Step 3 is to use the slope formula to find m. So I'm going to do that right here. All right, honey. I'll see you on Monday. Step 3 is to use the slope formula to find m. So what we're going to do is the formula. On top, it is y2, which is 5, minus y1, which is 3, over x2 minus x1. And we are going to simplify this. 5 minus 3 is 2, 4 minus 2 is 2, and that equals 1. So now I know that m equals 1. I'm going to circle this in green because I've been using green to represent my slope. Now let's go look at step 4. It says to choose one of the ordered pairs and substitute the slope and the point into y equals mx plus b. So let's choose one of these ordered pairs. Last semester, I said we can just go with the last one, but really it doesn't matter which one you choose. So I'm going to say 4, 5, and this is an x value, and this is a y value. So I'm now going to plug in those 3 pieces of information. So 5 is a y, 4 is an x, my slope is 1, and then I'm going to bring down the rest of the formula. And then remember, that's not 14, it's 1 times 4, so wrap that up in parentheses. Step 5 says solve for b. So let's finish solving this equation for the b. I have 5 equals 1 times 4 is 4. And then I'm going to subtract 4 from both sides. 5 minus 4 is 1. So I now know b equals 1, and I've been using blue for b. My final step is to substitute m and b back into the slope-intercept form. So y equals mx plus b. The slope is going to go in right here. That's a 1. The y-intercept is going to go in right here. That's also a 1. And then I'll keep y equals x plus b. And here's the equation I got algebraically. Here's the equation I got using the graphing method. And notice that we have the same line. Y equals 1x plus 1. So you can truly do either method. Let's go take a look at example 2. So I want you to start out doing steps 1, 2, and 3 on your own. I want you to identify the x and y values from the ordered pairs, write down your slope-intercept form of a line, and then use the slope to find the m. Pause the video while you do that. So I have identified my ordered pairs as x1, y1, x2, y2. I wrote down y equals mx plus b because I'm going to use that next. And then I found my slope by doing y2 minus y1 over x2 minus x1. Now that I have my slope, I need to choose one of my 2 points. Let's just use the second point. So I have 0, 4, and this is an x value, and this is a y value. So I'm going to plug those into the right places. X is 0. Plug my slope in, and then bring down the rest. All right, -3/2 times 0 is just 0. And you don't have to write 0 plus b. So I now know that b equals 4. And so now I'm going to put my b in and my m in. And then bring down the rest of the equation. And that's it. Again, both methods gave me the same answer. Here's what I'd like for you to do now. We have done both examples 1 and 2 together using both methods. What I want you to really do now, though, is to practice just the algebraic method in example 3. I have completely finished my example number 3, and I know that you probably could have gotten a good portion of the way through this pretty easily. And then you probably got stuck right here once you saw these fractions. So what I did was, in order to add these 2 fractions together, I went ahead and converted the number 2 into a fraction so that it would have a denominator that matches the 15 over 2. So times the top and the bottom by 2, that way the denominators here will match. And so I got 4 over 2. That helped me when I added 15 halves to both sides. Then I could just add the 4 and the 15 to get my 19, and then I keep the denominator the same. So remember, adding with fractions. If you're lucky enough to have a calculator, your calculator could also help you with this, but it is important that we remember how to work with fractions. Now, I didn't give you the option of trying the graphing method with this problem, and I did that on purpose because the graphing method wouldn't really be the very best way to do this. And that's because the y-intercept is a fraction. So when there are fractions involved in our equations, the graphing method isn't the best way to do it. There's also another time when the graphing method wouldn't be great, And that would be if the y-intercept is too big to fit on the graph that you have, or too large. All right, so those are two times when the graphing method probably wouldn't be the best. So we do need to practice our algebraic method. So I'd like for you to pause the video one more time and try example 4 and then check back with me. All right? All right, so far in example 4, what I've done is I've used my ordered pairs and I have found the slope using the slope formula. So the slope is -2. I do want you to remember that all we plugged in here were the -4 and the 15 and then the 2 and the 3. These minus signs in the middle, these are a part of the formula. So don't forget that. If you are substituting in, say, a negative number after the minus sign, that's going to cause some sign issues for some people. So just be careful. Now I'm ready to choose an ordered pair. Normally I choose the second one. I'm going to choose 2 and 3 because the numbers are smaller and easier for me to work with. So the 2 is an x value and the 3 is a y value. And we're going to plug those in to y equals mx plus b. So y is 3, x is 2, and then slope is -2. And I'm ready to solve. -2 times 2 is -4. Add 4 to both sides. And I find that my b equals 7. So this was not a good example of a y-intercept that's too large to graph. But what if you just have a teeny tiny little graph and it doesn't actually go up 7 places? So the algebraic method guarantees that you can always find your answer no matter what. Now I'm ready to plug my slope and my y-intercept into y equals mx plus b to get my final answer. So remember, the b goes in right here, so +7. The m goes in right here, it's a -2. And then we keep the y equals and then the x after the slope. And that's the answer for example 4. Here's what we're going to do with the remainder of our classroom time. You are going to work with a partner or individually based on what your teacher tells you, and you are going to complete examples 5 through 8. It is very important that we practice this method so that we can get really good at it. All right. And this is kind of a mixed review. I just gave you a slope and a point in examples 5 and 7. And then in examples 6 and 8, I gave you 2 points. So I do want you to practice all of these methods the algebraic way, or all of these examples using the algebraic method. So pause your video and then take some time and work through these and then come back and check in with me. So I have completed examples 5 and 7. I did those first because they require a little less work. Take a look at my number 5. If there's any questions that you have, or if you and your partner weren't able to get to a solution together, please raise your hand and ask me to come help you out, all right? and then down to example 7. And I know that some people would probably struggle with number 7 simply because of the fractions again. 7 times 2 is 14, over 8 times 1 is 8. So I had 14 over 8 as my fraction, and then I had to simplify it. So if you divide both 14 and 8 by 2, I got 7 over 4. So now I know that my denominator is 4, so I had to convert -3 into a fraction that had a denominator of 4, which was -12 over 4. Subtract the 7 over 4. Remember when you have two negative numbers, -12 and -7, you add the numbers and keep the negative sign. So -19 over 4 is my y-intercept. And then I took my slope and my y-intercept and I put them together for my final answer. Here is my work for example number 6. I had to find my slope first because I have 2 points that I was given. And notice that I had to do on the top of my fraction, -14 minus -2. And so when you see two negatives together like that, we need to remember that that changes to a plus sign. Let's go take a look at number 8. And here is my example 8. Same thing happened when I was using the slope formula. I had -10 minus -12, which changed that to -10 plus 12. So my slope came out to just 2, which was nice. I plugged in my slope, and then I chose the ordered pair 3, -10, and I plugged in my m, my x, and my y into my slope-intercept form, and I simplified to find the b. And this is a great example of my y-intercept being a number that is too large for me to graph very easily on a coordinate plane. So great job on today's lesson. You do have a practice assignment that is posted to Google Classroom. So go ahead and begin working on that now.